This work looks at the evaluation of endoscopically deployed radiopaque tumour models in bronchoscopy. The goal of this work is to develop a contrasting pulmonary tumour model that is easy to insert into the distal bronchial branches and which can form a soft tissue-like fiducial when placed. Two tumour models were developed as part of this work. The first was derived from a popular hydrogel, Agarose, and the second looked at utilising beef tripe as a potential model. The Agarose model also comprised of a contrasting medium omnipaque, the preservative dimetridazole to prevent microbial invasion, and food colouring. The Agarose model was prepared by heating the Agarose omnipaque and water solution to 70 degrees Celsius on a hot plate magnetic stirrer before adding dimetridazole. The mixture was further heated to 95 degrees Celsius to ensure total dissolution. Food colouring may then be added before cooling the mixture in a fridge, yielding a firm, elastic material. The locally sourced tripe was cut into rectangular segments and placed in a container filled with iodine and food colouring. The samples were left to soak overnight and were further injected with iodine immediately before use. Early Agarose tumour models were evaluated in a soft tissue explant following direct injection through a 21 gauge aspiration needle. CT imaging illustrates the clinically relevant contrasting ability of the Agarose models compared to the background intensity of the soft tissue analogue. Modified Agarose models were evaluated in a preserved swine lung model, inflated in a vacuum chamber. 8 tumour models were injected by an experienced operator in the left and right, upper, middle and lower lobes. Each model was injected in the liquid form before cooling to a radiopaque mass. The swine lung was subsequently scanned using CT and the resulting images clearly identify well-placed endobronchial fiducials. The Agarose and tripe tumour models were also evaluated in vivo during 3 preclinical investigations. The Agarose models were injected endoluminally with a catheter via a lower access port. After each injection, the catheter was removed and the working channel was flushed with a cold saline solution to promote rapid coalescence of the tumour model. The iodine-enriched tripe models were introduced through the endobronchial tube with a bronchoscope and endoscopic biopsy forceps. The tripe models were positioned through the manipulation of biopsy forceps in the upper and lower left and right lobes with real-time fluoroscopy to confirm placement. Both the Agarose and tripe models were sampled endoscopically subsequent to CT imaging. The resulting images from the CT scans identified a number of locations where the Agarose models were placed. However, in vivo placement of the Agarose model proved problematic, with many samples migrating away from the intended target caused by a high flow rate due to a prolonged liquid to gel transition time. Tripe provided a much more attractive in vivo solution as a pulmonary tumour model. The tripe model can be prepared quickly, deployed rapidly, and presents a clear image contrast under CT imagery. The Agarose and tripe fiducials visible under X-ray imagery were selected as target markers and were subsequently targeted under real-time virtual bronchoscopy